Hey, what's up? It's your old pal, Mr. Cook. We just got done with the second page of the fall final exam review. So now we're going to move on to the third page here. We're still dealing with polynomials, and remember that polynomials, that's like, unit 2 along with rational functions. So like, if you're confused about any of this stuff through, looks like number 26, all this is found like in unit 2. Okay, so like, explore some of those videos that we have or your old notes or some old homework assignments. Just kind of refresh your memory on the vocabulary that's used, because a lot of times the test and the group work problems are ones, like we recycle the verbiage a lot in the problems that we use on tests and final exams and stuff. So, if you're confused about what it's asking, definitely, ask your teacher for some clarification on how to handle the problem, what it's really trying to relate, like what ideas you're trying to show in each one of them. Anyways, so if you want to make a polynomial, put one together given zeros, like number 22 is asking us to do. You just got to remember that each of your zeros gives you a factor, okay? And if you multiply factors together, that gives you a polynomial. Because like your polynomials can be written out in factored form, where it's like, x minus 3 and x plus 5 and whatever. Well, each one of those little factors that you get are based off of individual zeros. It's like, each factor is just x minus whatever that zero is, like your first zero or your second zero, they just go in there. It's like x minus that. So like when you have 0, -3, and 2, you can put together a couple of really easy factors for your polynomial. Your polynomial for this one, the polynomial that has these zeros, is equal to x minus 0, x minus -3, and also x minus 2. And then, you just make it look a little bit nicer. X minus 0 is really just x. X minus a -3, that's really x plus 3. And then x minus 2, that's as simplified as it gets. From here, it just kind of depends on the question. If it's asking you to, expand on it as well, just FOIL here and then multiply the x in, and get another polynomial. I'll just do that real quick. So like if I FOIL here, x times x is x squared, x times -2 is -2x, 3 times x is 3x, 3 times -2 is -6. We still have the x outside, and then let's combine like terms. So it becomes x squared plus x, and then minus 6, then distribute the x in, and you get x to the third plus x squared minus 6x. And that would be your polynomial all expanded out instead of just in factored form. So like, either of those answers would probably be the ones that we're looking for on the test, on the final. Find the fourth degree polynomial function that has the following zeros: 1, -1, and 4i. Well, this doesn't outwardly say it, but 4i, whenever you're given an imaginary number, you're also given its complex conjugate. In this case, it would be -4i. You just change the sign on the I value, basically, to get that other one. So the first two are pretty easy for our polynomial. We've got f of x is equal to, and then it's going to be x minus 1. And that one, x minus -1, so x plus 1. And then this last one that we have, 4i and -4i, you can like, you can write it out, just the way that we're doing it. So like x minus 4i, and then also x minus -4i, so in other words, x plus 4i, and then like FOIL everything together. But there's like a shortcut that I've been kind of showing people how to like, solve this. And that's like this. You set x equal to plus or minus 4i, and then you just get 0 on this side. So like square both sides, so you get rid of the I. So if I square 4, that's 16. And if I square I, that's -1, so -16. And then just move the 16 over, so you get x squared plus 16. And that is your other factor. So, I mean, you can move that in there as well, x minus 1, x plus 1. And then this stuff will FOIL out to be that x squared plus 16. And, like what I was saying before, it might ask you to solve it in factored form like this or expand it. Just be prepared to, distribute in there if you need to. Okay, write the equation for the following. So this is really just kind of like hiding this information, the zeros. So if you can get the zeros, it's just the same exact question, right? So, the other thing that it puts in there also is like that you have like some of the zeros that are bouncing off the axis, which implies that they're going to have an even multiplicity, so like a multiplicity of 2 or 4 or 6. But, since these are 4-degree polynomials, these are probably just going to have multiplicities of 2 for each of them. So our 2 zeros, the zeros are the x-intercepts. One zero is going to be at -1. Another zero is going to be at +1. And then each of these have a multiplicity of 2, and I'll show you how to get that in a second. Well, how to use that in a second. But multiplicity just implies, like, if it bounces off of the zero at that point, it's an even number. And usually go with the smallest number, 2. And sometimes it's an odd number. It's an odd number if it like passes through. Like this one will pass through, so it'll have an odd multiplicity. So you can say that multiplicity is like 1. So like, it looks like we're gonna have to, I'll just go through these ones also to kind of like compare. So like at this 0 right here of -4, so x equals -4, the line passes directly through the x-intercept instead of bouncing off of it like these ones do. Okay, so that implies that I have an odd multiplicity, and the smallest odd multiplicity would be multiplicity of 1, especially since we have a 3rd-degree polynomial. So each of these have multiplicity of 1s because it just passes right through the x-axis. So there's another one that we have, another 0 at 1, and then another 0 at 3, and they're all probably going to have multiplicities of 1 just because it like passes right through there. So how does this look as a factored polynomial? Well, the multiplicity is just the power on each of the factors. So if the factor for this one, -1, is x plus 1, because that's what makes, this is 0, -1. If you plug it in, this gets to be 0. The multiplicity is equal to 2, so that means it's just to the power of 2. And then you put your other factor on there, 1, so x minus 1. And that has a multiplicity of 2, so it has a power of 2. And this is the factored form of your polynomial. Now moving on over to this one, same idea. You just have all your factors, but now they just have powers of 1. So we can just like, it's like kind of a arbitrary, so you don't really put like to the first powers. You can just leave it as it is. So -4, so we've got x plus 4, 1, so we've got x minus 1, and then 3, so we got x minus 3. And then you can write to the first power on them, but that's probably not how it's going to look as an answer on a multiple choice exam. It'll probably just have no 1s on it. So you just got to get used to seeing that as well. Okay, really quickly sketch the graph of this. All right, I'll just do a really like kind of basic way of doing it. But you do realize that you have your graphing calculator, so you can always like graph it out. Like think about how this will look at as a multiple choice question. They'll give you this, and then probably some graphs, and you just need to like pick the right graph. So like, use your graphing calculator. But I'll show you how to do it pretty easily. X to the 5th, so x means that just like this x over here, that we have a 0 at 0. So just put a 0 there, and then x plus 2 implies that we have another 0 at -2, 1, 2. And then -1 means we have a 0 at 1, so 1. Now let's look at the multiplicity. So this has a multiplicity of 5, meaning that it goes directly through the graph. This one has a multiplicity of 3, which means it goes directly through that point as well. The graph goes directly through the x-intercepts. And then x minus 1, so at 1 it's an even multiplicity, so that means it bounces off the axis. The last thing you need to do is just do the end behavior. So the end behavior, we have a total degree value of, let's add up the degrees for each of them, 5, 3, and 2. 5 plus 3 plus 2 is 10. Since it's even, it's either going to be facing up and up or down and down. And then for the direction, we just look at the lead coefficient, which is a positive 1. So it's going to be this one right here, pointing up and up. So the graph starts by pointing up. It ends by pointing down, up again. Oops, not down. Ends by pointing up. And then in the middle of the graph, it goes like this. It goes to this point, and then since it's an odd multiplicity, it passes through, goes to this point, and then since it has an odd multiplicity, it goes through, and then it goes to this point, and since it's an even multiplicity, it bounces off of the axis and goes in this direction. So that completes our graph. And if you type it in your calculator, it'll look pretty close to that. Obviously not as beautifully drawn as my graph, but definitely more accurate. Okay, so that's this one. Now let's go ahead and do this one. Find the zeros and use them to sketch the graph. Let's skip the sketch the graph part because again, calculator. Let's find the zeros for it though. But again, use your calculator to find the zeros. Y equals, type it in, x to the 3rd power minus 4x to the 2nd power minus 4x. And then plus 16. Hit graph. So we got a 0 at 2, a 0 at -2, and then a 0 at 4. And since we have a degree 3 polynomial, those are our zeros. X equals -2, and 2, and 4. And you can always verify that if you have some time. Go to your table and just, negative 2, 0, 2, 0, 4, 0. Yep. So those are zeros. Cool. There's the answer. And you can graph it out, obviously, if you want. Okay, so from 27 all the way through, looks like 43, we are dealing with logs and exponents, one of your favorite topics probably. I know it's one of mine. And that's all unit 3. So, if you need to kind of remember some of the properties and all that stuff for logarithms, just go ahead and check out one of those group works or the extra practices. Okay, so let's see here. First, write ax equals b in logarithmic form. So that's just, you have to remember the formula for that. To write it as a log, you have log with a base of a of the value b equals the power x. So there you go. Then, do the opposite here. So the base c for the log becomes the base of an exponent with the power of a, and that's equal to t. Oh, look at that, it's a cat. Like a little cat. There's a little cat for you. Let's see, use the change of base formula to evaluate the following. So you don't have to do that. Like, think about it. We're not gonna if we do have show the equivalent log, you can just type it in your calculator, but I'll do what they're asking me to do. And then when we get to the multiple choice thing, I'll show you how to do it on your calculator. But for this one, if you use the change of base formula, it means that you take the log of the big number over the log of the small number. That's it. So that's that one. Then, same thing over here. So log of the big number, log 3, or log of the small number, log 8. And this will be log of the big number, x, over log of the base, a. There you go. Rewrite that as a single logarithm. Okay, so you got to remember a couple of log rules. When the logs have a number that's in front of them, that becomes an exponent. If they're positive logs, those go in the numerator. If they're negative logs, those go in the denominator. So it'll look something like this. Log, one big log. It's going to be 4 to the second power plus 3, so times 3 inside the log. And then negative 2, so over 2. So 2 goes in the denominator. And then you can just, evaluate it. So log of 4 squared is 16. 16 divided by 2 is 8. 8 times 3 is 24. There you go. There's your answer. All right, write the expression as a logarithm. As the logarithm of a single quantity. So we're just condensing these ones. There's a bunch of practice for condensing logs as well in other videos. Oh, excuse me. All right. So one thing that you can do here is distribute the 1/4 into all of these. I guess now thinking about the multiple choice, they kind of tend to do this a little bit differently, when we're looking for the answers. The 1/4 stays as kind of like this overarching power that we raise everything to, like a fourth root, because that's like the 1/4 power. So I'm just going to keep it consistent with that. So I'm just going to have a big log here, and now it's like a fourth root, like that, okay? And then we just follow the rules that we had for this previous one. Anytime that you have a multiple that's out front, then that becomes a power. And anytime that you have a negative log, that's in the denominator. So here we go. We have x plus 3 in the numerator because it's positive, and it has 2 out front, so that's the second power. We have x, and it's negative, this log is negative, so we have x in the denominator, and it has a power of 4, so x to the 4th. And then we also have this x squared minus 1. It's a negative log, so that goes in the denominator, and it doesn't have a power attached to it. So this is the finished logarithmic expression, just using those log rules. The last one that we have, write the expression as the logarithm of a single quantity. We're doing the same rule over here. Looks like these are all positive. So let's go ahead and write it up. So log of, and then c, and times a, times b, times, oh geez, that's stupid, log cabin, I mean, really clever and funny. Anyway, so that's the last problem on this side. Remember, this is all Unit 3 stuff, logs and exponents. If you need to remember some of that, definitely check out some of those videos or other videos. You know, like check out Khan Academy or anything like that that focuses on logs, condensing and expanding primarily. All right, that's it for this page. Move on to the next page where we continue on with logarithms for a good chunk of it, and then a little bit of sequences at the end. All right, that's it for this one. See you on the next video.